Welcome to the loop commissioning video tutorial. An induction loop system project involves two critical phases. 1. Installing the loop wire, and 2. Commissioning the amplifier. In this video, we'll guide you through phase 2, commissioning the loop system. If you haven't already, we strongly recommend watching our induction loop installation video before proceeding. Commissioning ensures your system meets the IEC 60118-4 standards for hearing loops and maintains ADA compliance. Before starting, make sure, number 1, a background noise check has been completed using a field strength meter. Number 2, the loop wire is installed according to the Williams AV loop design. And number 3, the lead wires are soldered to the loop wires and ready for connection to the amplifier. To commission the loop system, you'll need the following items: the loop amplifier, a PC with the Digi-Loop PC app installed, a USB cable or Ethernet cable, and a field strength meter, part number PLM FSMP. If you need help, refer to our video, PC app walkthrough. Since phased arrays are the most common, we'll cover commissioning this type of loop design in this video. If you have questions about commissioning other loop types, feel free to call the TechServices group at Williams AV. Start by reviewing your loop design. Note the direction of current flow indicated by the arrows. This defines polarity from the amplifier's positive terminal through the loop and back to the negative terminal. Each lead should be clearly marked as A+ and A- for loop A, and B+ and B- for loop B. Now, using the Phoenix connectors on the loop outputs on the back of the amplifier, number 1, strip the 14 gauge wires. Number 2, insert A+ and A- into channel A, observing polarity. Number 3, tighten the screws securely. And number 4, repeat for loop B into channel B. Now power on the amplifier. If a fault message appears, stop and check the wiring. Possible issues include open circuit or short circuit. If an error is displayed on the front of the unit saying the amplifier has shut down, you will need to troubleshoot it. To do this, remove the Phoenix block from the affected channel, then use a multimeter set to ohms, and measure the resistance across the screws on the terminal block. This is the total resistance of the loop and the lead wires together. If you get a reading greater than mega ohms, this would indicate an open circuit. And if you get a reading less than a half an ohm, this would indicate a short circuit. At this point, you will need to fix any issues with the loop if found, such as a short or open circuit. If there's a break, you'll need to use a toner to locate those breaks. Once the loop is repaired, reconnect the Phoenix block and power the amplifier back on. The amplifier will run another loop check and display any errors if found. Section 2. Connecting the PC app. Now with the loop loads verified, connect your PC to the amplifier via USB or Ethernet. Then launch the Digi-Loop PC app and establish communication to the amplifier. If you need help, refer to our video, PC app walkthrough. Section 3. Calibrating the amplifier. Once connected, we'll start by loading the factory default preset for phased array. Click on the Presets tab, select Phased Array from the drop-down menu, and a prompt appears asking to confirm the selection. Choose Yes. Now we can begin calibrating. Calibration aligns the system with the IEC 60118-4 standard, ensuring a 0 dB field strength at 1 kHz, measured 5 feet, chest height from the floor. Step 1. Open the calibration control window. Step 2. Select or make sure loop A is selected. Step 3. Set the frequency to 1 kHz. Step 4. Prepare your field strength meter. Set it to normal and the 0 dB scale. Step 5. Walk out to the loop's center. Then hold the meter vertically at chest height. Please note, while taking readings, the meter must be held in a vertical orientation. If it's tilted, the readings will be inaccurate. Now, using the volume slider in the calibration window, adjust it until the field strength meter reads 0 dB. If we are commissioning a phased array system, switch to loop B in the calibration window. Now adjust the offset current so the current matches between A and B. This will be shown at the bottom of the window. Then finally, switch to A plus B mode and go out and take readings. We want to make sure the field strength is still around 0 dB. To do this, walk the room holding the meter vertically at chest height. You may see fluctuations, but the levels should stay within plus or minus 3 dB from the 0 reference point. Very important. When this is completed, do not change the test tone volume after this step. EQ adjustments have their own volume controls, and we'll cover those next. Section 4. Equalizing the amplifier. Now we'll equalize additional frequencies to the 1 kHz reference, ensuring a flat frequency response across the listening range. These parametric EQ points will be used: 100 Hz, 500 Hz, 2.5 kHz, and 5 kHz. To do this, open the FX window. Set the EQ points to those frequencies. You can double-click each value to enter it manually. Note, higher frequencies such as 2.5 kHz and especially 5 kHz may be harder to balance due to metal loss, so in those cases we aim for as close to 0 dB as possible. While doing this, watch the current draw. For the DL107 and DL207, the maximum is 7 amps per channel. For the DL210, the maximum is 10 amps per channel. If this level is exceeded, reduce the EQ gain to avoid overload. Now we'll repeat this process for each frequency. Set the tone generator frequency in the calibration window, go back into the FX window, and adjust the EQ's gain to hit 0 dB on the field strength meter. Monitor the field strength meter and amplifier current throughout. When finished, we can close the calibration window. Section 5. Performing a listening test. Once the calibration and equalization process is finished, we'll test with the venue audio, the input source the amplifier will use regularly. Confirm the audio input shows activity around 0 dB in the PC app. If it is not bouncing around 0 dB, adjust the gain at the source. We only want to adjust the gain at the amp if there's no other option. Now, using a loop receiver with the volume set at either 2 or 3, the audio should be clear and appropriately loud. Please note, the field strength meter can also be used as a loop receiver by plugging a headphone or earphone into the headphone jack of the field strength meter. Section 6. Backing up the configuration. It's best to save your settings in case the amplifier needs to be reset or replaced. To do this, in the PC app, click on the floppy disk icon. Then save the file. The default name will be digiloop.config. This can be renamed for the project you're working on. Then, to restore it later, use the folder icon to load the saved file. Section 7. Locking out the front panel. It's highly recommended to lock out the front panel to prevent unauthorized changes. In the amplifier menu, go to System Configuration, then Security, select Set Configuration Password, enter a 3-digit password, and then write this down and save it in a secure location. If the password is lost, you can still connect a USB or Ethernet cable and perform a factory reset in the PC app to regain access to the front panel. Section 8. Final sign-off. Now it's time for final approval. Invite the facilities manager or responsible party to walk the looped area with you. Let them listen using a loop receiver or a telecoil-enabled hearing aid. Use typical venue audio during the demo. While doing this, explain that loop systems are designed for speech clarity, not high-fidelity sound. Once they confirm with you that system performance is acceptable, present the loop certification form. Note that at this point you should have the values filled out on the form. You can download this from the Williams AV website under Support, Documentation, and Firmware. Search for Certification. Then, Complete the form and have it signed by the facilities manager, and then you sign it also. This establishes a baseline and helps identify if future issues are due to tampering. The form also serves as proof that the system was commissioned to the IEC standard and is therefore ADA compliant at the time of commissioning. Also, any future service calls may then be potentially billable. Thanks for watching this loop commissioning video. Be sure to check out our other videos such as PC app walkthrough and induction loop installation to learn more about the entire loop system implementation process. As always, if you have any questions or need support, you can reach the Tech Services and Design Department by emailing us at techservices@williamsav.com. For any sales inquiries, email us at info@williamsav.com.